This lesson is about ratios, rates, and unit rates. So here we have a basketball contest. Elizabeth made 9 out of 25 free throw attempts and Alex made 8 out of 20. Janie says Elizabeth had a better free throw record because she made more free throws than Alex. So what do you think? So for this problem, a couple different ways we can do this. A lot of times if you watch basketball, you'll see a statistic about free throw percentage. And that would probably be the easiest way to figure this problem out. Figure out what percent of their shots did they make. So for example, Elizabeth made 9 out of 25. So she made 9 out of 25 shots. If we want to find a percent, we know a percent is a number out of 100. So we can find an equivalent fraction here. We can figure out 9 out of 25 would be equivalent to how many out of 100. This has a nice pattern to it. If we did 100, that'd be 4 times as many shots attempted. So we're going to guess 4 times as many shots made. So 36 out of 100, which means Elizabeth made 36% of her free throws. Alex made 8 out of 20. And again, this works out really nice. 8 out of 20. If we're trying to get that to be 100, 20 times 5 is 100. 8 times 5 is 40. So that's 40 out of 100, which is 40%. So Alex made 40% of his shots. So you can see here, actually, Alex had a little bit higher percentage. Neither one the greatest percentage, but he was the higher percentage out of the two. If these numbers weren't quite as nice here, like they were on this problem, let's say Elizabeth made 2 out of 7 free throws, for example. If she made 2 out of 7, and you can do this for anything, whether it comes out nice or not, but especially 7 wouldn't go into 100 really nicely. What you can always do to change these to percents is by dividing. Remember, numerator goes on the inside, so 2 divided by 7. We can just put a decimal and some zeros here. So 7 would go into 20 2 times. 7 goes into 60 8 times. Seven goes into 40 5 times. Okay, and then what you do, this would keep going, but once you get finished here, you would just move your decimal over 2 spots. So you can see this would be a little over 28%, 2 out of 7. Just going to look at a couple of definitions here. First of all, a ratio is a comparison of two things by division. So for example, we've got 60 over 2. We've got 1 and 50 hundredths over 3. Those would be examples of ratios. You guys have done stuff with this before, ratio, like ratio of cats to dogs. So there's 5 cats and there's 3 dogs. Ratio of cats to dogs would be 5/3 or 5 over 3. Okay, so that's a ratio. Now, if we add some units to these, so 60 miles for 2 gallons, $1.50 for 3 pounds. Adding the units, when they have the units in them now, these would be examples of rates. So without the units, they're just ratios. We add the units, now we can call them rates. They're still ratios, it's just kind of a special name we give to ratios that have units with them. And then branching off of that, we can talk about unit rate. Unit rate is a ratio with a denominator of 1. So for example, we take our 60 miles for 2 gallons, and if we would divide both of those by 2, divide the 60 and the 2 both by 2 here, then we would get 30 miles for 1 gallon, or you might hear as 30 miles per gallon. $1.50 for 3 pounds, if we divide both of those by 3, that would give us 50 cents per 1 pound, or 50 cents per pound. Basically, instead of saying, well, I'm going to divide this first one by 2, I'm going to divide this second one by 3. If you take these rates, take your rate, if you just take the numerator divided by the denominator, that will give you your unit rate. So $1.50 divided by 3, that'll give you the 50 cents per pound. So you can always just divide the numerator by the denominator, and that will give you your unit rate. So we look at our problem here. Nathan and Dan were both hired as lifeguards. They received their paychecks for the first week. Who earns more per hour? So we're talking about earnings per hour, how much they earned per hour. So you can see here's the earnings, here's the hours. When you see the word per, that means you can divide. Earnings per hour, we need to take the earnings divided by the number of hours. That'll give us our earnings per hour. Okay, so the book shows us a little different. We'll talk about in just a minute here. But basically for Dan, to find his earnings per hour, we would want to take $78.75 divided by 9. Okay, you divide that out. That would tell you how much Dan earned per hour. Same thing for Nathan. We could take $46.25 divided by 5. And that's basically what the book's doing over here. Okay, when you divide that out, so this one here would be $9.25 per hour. The first one we had over here would be $8.75 per hour. Okay, again, just divide it out, find your unit rate. So you can see there the $9.25 is the higher unit rate by 50 cents. If you just subtract those, $9.25 minus $8.75, you can see Nathan's earning 50 cents more per hour. So similar problem here. Jennifer is a lifeguard also. She's earning $137.25 for 15 hours. How much does she earn per hour? So basically the same concept here. We want to find out how much she earns per hour. Take her earnings per hour, earnings divided by hours. So 137.25 divided by 15. 15 is not going to go into 1 or 13, but it's pretty close. So if we try 15 times 9, 9 times here, that's going to work. 15 goes into 22 one time. 15 goes into 75 5 times. So you can see she's getting $9.15 per hour. So we can compare that back to the people we talked about in the previous problem. You can see she's making somewhere in between. She's not making the most money out of the group, but she's not making the least money either. So we look at example 2. Brian has agreed to watch his neighbor's dogs for 7 days, and his neighbor provided a 128-ounce bag of dog food. Does Brian have enough food to feed the dogs all 7 days? Okay, so again, kind of highlighting the key parts to the problem here. So if we look at the information here, we don't know how much each of them ate in one day. For Buster, we know 2 days, and for Roxy, we know for 3 days how much they ate. What we can do, though, we can figure this out. Basically, for Buster, if we just find the unit rate, so 20 and 5/10 divided by 2, if you just divide that out, actually, you don't have to exactly do what the book's doing here. If you just divide that out, you'll get 10 and 25 ounces per day. So that's for 1 day. We want to know for 7 days, so then we multiply that by 7. And you can see Buster would need 71 and 75 ounces for 7 days. Roxy, basically the same idea. We know for 3 days. So if we just divide this out, 22 and 5/10 divided by 3. You divide that out, you'll get 7 and 5/10 ounces per day. That'd be for 1 day. We want to find for 7 days, so we will multiply that by 7 again. And that would be 52.5 ounces. So now we know what each of them would be needing to eat for the 7-day period. We can just add those together. You can see here they added those together and they got 124 and 25 That's how many ounces we would need all together. And they had a 128 ounce bag, and so they would have enough food here. I even have a little bit of crumbs left over for the dogs here. Okay, maybe safer to buy a little bit more dog food, but they could get by with that, looks like. Example 3, we're looking at a rabbit and a kangaroo rat. It says, suppose each jump covers the same distance. When they say that, what they're actually meaning, it's not worded the best, what they're actually meaning is the rabbit, each time the rabbit jumps, the rabbit is jumping the same distance each time. Each time the kangaroo rat is jumping, the kangaroo rat is jumping the same distance each time. Okay? So the question here is, how many jumps does it take each animal to cover the same distance? So what they did here in the book, they made a table. So they looked at this, they see the rabbit jumped 3 times and it went 8 meters. So this was already given to you. 3 jumps, 8 meters. Kangaroo rat, 5 jumps, it went 12 meters. Obviously their distances are not the same, so we want to get them to have the same distance. Well, like I've got over here, this is actually kind of like getting a common denominator. And you might say, well, how does that have anything to do with getting a common denominator? Well, we can put the jumps, we can make that be our numerator. We can make the meters or the distance be the denominator. So 3 jumps was 8 meters. If 3 jumps was 8 meters, we'll just imagine we didn't have this over here. 3 jumps was 8 meters, 5 jumps was 12 meters. What we're trying to do, we're trying to get their distance to be the same, which is the denominators here. So that's how has to do with getting a common denominator. It's kind of that same idea. So if you look at the 8 and the 12, or if you look at the table, the 8 and the 12, we're trying to get those numbers to be the same. So what we need to do is find the least common multiple of 8 and 12, or imagine that, if these are denominators, what's my least common denominator? Well, 8 doesn't go into 12. The next multiple of 12, though, is 24. 8 times 3 is 24. So 24 would be a common denominator. And then basically it's just a matter of, what did we have to do to get from, in this case, what do we have to do to get from 8 to 24? Would be multiplying by 3, so we'll do the same to the numerator. So 24 meters, the rabbit went got that distance in 9 jumps. For the kangaroo rat, 12 to 24 would be multiplying by 2. So multiplied by 2, you could see 10 jumps, it went 24 meters. So pretty close here. You know, just the difference over a 24 meter period, it only took the kangaroo rat one more jump than the rabbit. So, you know, one less jump for the rabbit, but pretty close there. So we've got a kitchen sink faucet that's streaming 5/10 of a gallon of water in 10 seconds, and a bathroom sink faucet that's streaming 75/100 of a gallon of water in 18 seconds. Which faucet will fill a 3-gallon container faster? Alright, so basically, really on this problem, it doesn't matter necessarily how big this container is. It happens to be a 3-gallon container, and we can work with that as one option of doing this problem. Really what it boils down to, though, is which one of these faucets is streaming the water faster. Whichever one streams it faster, it doesn't matter if it's a 3-gallon container or a 50-gallon container. The one streaming it faster is going to always be faster overall. So one option you could do to figure out how fast it's streaming the water, we could get a unit rate. So the kitchen sink is 5/10 of a gallon in 10 seconds. So if you do this, gallons divided by seconds, that'll give you gallons per second. Basically here we're just dividing by 10s, just going to move our decimal over one spot. For the kitchen sink, the bathroom sink, 75/100 of a gallon in 18 seconds. So we can divide this out, maybe 18 times 4 would be 72. And we can add a 0 here. 18 goes into 30, would only go one time. Okay, and this keeps going, but I've got really enough information here already. Notice in our hundredths place, this is 5/100 exactly. This one's got a 4 in the hundredths place and then some numbers behind it. Okay, it doesn't really matter at that point because this one over here has got a bigger number in the hundredths place, so it's going faster. So the kitchen sink faucet is going to fill this container faster. Okay. Another way we could do this, if you wanted to, we could actually look at that 3-gallon container. So we know 5/10 took 10 seconds for the kitchen sink. So what you could do is you could just think about how many 5/10 is like the same as a half gallon. So you could think of how many half gallons do you have in 3 gallons, or you can just get this up to 1 gallon if you want to. You know, half gallon took 10 seconds, 1 gallon would take 20 seconds. Okay, just 2 times as much there. And then 3 gallons, well, from 1 to 3, that's 3 times as much. So 3 gallons would take 60 seconds for the kitchen sink. And then for the bathroom sink is 75/100. 75/100 you might recognize, like 75 cents is 3/4 of a dollar. So 75/100 is like 3/4. You might look at that and say, well, how do we get from 3/4 to 3? Well, what we can do, just think about 3. Think about how many fourths that's equal to. Okay, so 3 is like 3/1. How many fourths is that equal to? So we're just finding an equivalent fraction. So 3 is equal to 12/4. So, you then how do we get from 3/4 to 3? We would need to multiply by 4, because 3/4 is what we have right now. And 3 gallons is 4 times that much. Okay, so if that took 18 seconds, and then 4 times as much we could do would be 72 seconds. So there, again, you can see the kitchen sink faucet is faster. They could have said how much faster, which one would be faster and how much faster would it be. And in that case, we would really probably need to work it out this way, would be easier. Because then we can see here the difference between this one was 60 seconds, this was 72 seconds. We can see the kitchen sink was 12 seconds faster. Let's look at number 2. Dorian buys 2 pounds of almonds for $21.98 and 3 pounds of dried apricots for $26.25. Which is less expensive per pound? And how much less expensive? So we can look at our table here that they've gotten started for us nicely. You can see for the almonds, 2 pounds, it was $21.98. And the dried apricots was $26.25 for 3 pounds. So it asks which one's less expensive per pound. So finding the cost per pound for the almonds then, we could just divide that out. So we could just take $21.98 divided by 2. Which is $10.99, so $10.99 for 1 pound. And the apricots was $26.25 for 3 pounds. Again, let's just find that unit rate. 3 into 26 goes 8 times. Into 22, 7 times. Into 15, 5 times. So that would be $8.75 for 1 pound. So the first question, which one is less expensive per pound, we would say would be the dried apricots. And then how much less expensive, we would just subtract those. So $10.99 minus $8.75 would be $2.24. So we could say the dried apricots are cheaper by $2.24 per pound. Okay, so that would be our statement. We can make that concise and just make it into one sentence if we want to. Okay, let's look up here at number 4. So number 4, Crystal is comparing 2 internet service plans. Plan 1 costs $34.99 per month. And plan 2 costs $134.97 every 3 months. If Crystal plans to stay with one service plan for 1 year, which should she choose, and how much will she save? Okay, so we're answering a couple questions. Obviously, well, not obviously. At this point, even, it may not be real apparent which one's even the cheaper way of going. There's a couple ways you can do this. One way, we could just find the unit rate for the other plan as well, and then figure out from there, figure out how much she would save per month, and then figure out how much she would save for a year. Or we could just get both of these to being a year. I'm just going to get them both to a year, but again, whichever way you do this, you should come up with the same answer. So $34.99 per month. So we're trying to find for a year, so a year would be 12 months. So we'll just multiply that by 12. Just so you're not watching me work all this stuff out here, if we just multiply that out, that's going to be $419.88 for the year. Now plan 2 is $134.97 every 3 months. So that's for 3 months. So let's think about this. How many 3s do we need before we get to 12 months? 3, 6, 9, 12. We need 4 of them, don't we? Okay. So we would need 4 of these 134.97s. So 134.97 times 4 would be 539.88. So now should be a lot easier to see what's going on. Obviously then plan 1 would be cheaper. And if you just subtract those, that would tell you your difference here. Like we talked about, you label your steps here, makes it easier for somebody to look at, and easier for yourself to look at too if you're trying to figure out if you made a mistake on something, what kind of mistake you made. Okay, so the difference is $120. So we could say then that plan 1 is cheaper by $120 for the year. Number 5, we've got some people reading here. So Pam is reading 126 pages in 3 hours, and Zach read 180 pages in 4 hours. If they continue to read at the same speeds, will they both finish the 125-page book after 5 total hours of reading? Alright, so if we look at this for Pam, 126 pages in 3 hours. If I'm going from 3 hours to 5 hours, that's not a real great transition there. If it was 6 hours, I know I'll just double it, but 5 hours, we're not going to quite be able to tell that. So what I would recommend here for Pam is let's figure out how much she's reading per hour and then go from there. So pages per hour, take the pages divided by the hours. So 126 divided by 3 would be 42. So 42 pages per hour. Okay, this is for Pam. 42 pages per hour. And so we're going to see in 5 hours how much she would be able to read. 210 pages. Not quite enough. So she'd fall 5 pages short, technically, in the 5 hours here. Okay? And then Zach. Zach's in 4 hours, so that doesn't quite work out either, going from 4 to 5. So if you do 180 divided by 4, that would be 45 pages per hour. And then normally what I would do, we could go ahead and just take 45 times 5. Another trick you could do with this one, you could just say, well, 180 pages in 4 hours. If we're going 5 hours, that'd just be one more hour. So you could just take 180 plus 45 and see what you get. But we'll pretend we didn't see that. It's not a big deal. Okay, so Zach would be able to read 225 pages. So he would have enough time reading it all in 5 hours. Okay, so if we were going to write that out, we could say something like, after 5 hours, Pam would still have 5 pages left. Zach would be able to finish the book in 5 hours. Okay, and again, your work kind of explains that a little bit. You could go into a little bit more detail, though, also. Okay, number 6, Nora and Eli are making homemade spring rolls for a party. Nora can make 8 spring rolls in 10 minutes. Eli can make 10 spring rolls in 12 minutes. If they each make 40 spring rolls, who will finish first? Okay, so the race is on here. This one we're finding a set amount here. And probably what I would do first is check out these numbers and see how well these numbers work. If they're going to make 40 of these, they tell us how long it takes this person to make 8. They tell us how long it takes this person to make 10. Probably the first thing I would do is kind of look at this and say, well, if I'm going to make 40 total, does 8 go into 40 evenly? Does 10 go into 40 evenly? The answer is yes. And so I might be tempted just to make a table here. Okay, rather than time, we could just start out by just saying minutes would be fine. So Nora was 8 rolls in 10 minutes. Eli was 10 rolls in 12 minutes. So then, the question is, well, how do we get from 8 to 40? And when we're doing this, we're always looking for either a multiplication or division. We can't add or subtract. We're not going to add or subtract to find our patterns here. Going from 8 to 40, you can see that'd be 5 times as many rolls. So 5 times as long it would take her if she can keep her endurance here. So that would be 50 minutes for Nora. And if we look at Eli, he's going starting with 10. So 10 to 40, that'd be 4 times as many. So 4 times as many would be 48 minutes for him. And so you can see here Eli would finish first. And more specifically, we could say that Eli would finish 2 minutes faster than Nora. So this gives you an idea of how to work with ratios, rates, and unit rates.